Hello everyone, I am Sumon Biswas. I am a computer science PhD student at Iowa State University. My supervisor is Professor Ridesh Rajan. Today I am going to talk about my paper on fairness of machine learning models. This work has been accepted in Foundation of Software Engineering Conference ESEC FSE 2020. In this paper, we have conducted an empirical study on the fairness of machine learning models collected from a crowdsourced platform and their mitigation techniques, and finally, the impact of mitigations. So, what is software fairness? We call a software unfair when it discriminates people based on their societal attributes such as race, sex, or age. We call these attributes protected. When some privileged group gets systematic advantage over the decision of the software, it is not fair. For example, when a bank approves loan based on the records of the client, it should not discriminate based on the race of the individuals. Broadly, we have been studying the dependability of the data-driven software from a while. At present, a lot of data-driven software are being developed and used, and many of the decisions made by this software directly affect human lives. For example, we have seen the uses of software in credit approval, hiring employees, make decision of the admission, and even in jurisdiction of courts. Recently, many of these software have been reported to discriminate people from different societal groups. This is an example that demonstrates that need to remove societal bias from software. So COMPAS is a software developed by a company Northpoint. It predicts future crime risk for defendants. It has been used in many US courts in at least 10 states, including New York, Wisconsin, California, Florida, Arizona, and Colorado. A study showed that the software is discriminating between different races. For example, the person in the left has been assigned low risk even though he had history of two armed robberies and one grand theft. On the other hand, the person in the right has been assigned high risk while she had only the history of juvenile misdemeanor. Clearly, the software is exhibiting racial bias. A similar thing happened for other two examples. In overall, 44% of African Americans have been labeled high risk, but they did not reoffend. We want to detect and mitigate such bias from software. Here is an overview of our work. We wanted to study how fair the models that are written by machine learning practitioners. So first we created a benchmark of ML models from Wild, and then we have answered these three research questions. The first question is basically, are the models exhibiting bias at all? If yes, what are the measures? And the second question is, what are the root causes of the unfairness and what mitigation technique is successful? Thirdly, while applying the mitigation techniques, what are the side effects and impacts we observe? To create the benchmark, we have collected models from Kaggle using a set of filtering criteria. And finally, you can see we have collected models from these 5 different categories. In each category, there are 8 models. In total, we have got 40 ML models to analyze. We have used a comprehensive set of fairness metrics to measure fairness. Here are the definitions of the metrics. We have used both fairness, the group fairness and individual fairness. After the detection comes the mitigation. In the machine learning literature, 3 different kinds of algorithms have been proposed to mitigate the unfairness: pre-processing, in-processing, and post-processing algorithms. In our empirical evaluation, we have used 7 mitigation techniques on each of the 40 models. Here are the names and definitions of those mitigation algorithms. Our study highlights a number of findings. For example, we reported a few model constructs that directly impact the fairness. Library support is extremely necessary for the developers to make use of these constructs. So thank you for listening to the talk. If you want to read the full paper, you can find the preprint by typing this URL or by scanning the QR code. Have a good day. Thanks again.